Now, before we get started with Chapter 1, are there any questions on any of the assignments so far? Okay. Now, today's going to be really the first day we're actually digging into kind of trigonometry or something that you may not be as familiar with. And the first thing we're talking about is angles. Making sure. Okay. Yep. You're good. So you have a note sheet for y'all today. So the first thing we're talking about is angles. Now, just by definition, an angle is two rays with a common endpoint. That's just how we define an angle. And the vertex is going to be the endpoints, the common endpoint for these two here. Common endpoint of the two rays. And this here is something that you should be familiar with geometry. This is just how we define an angle. Now, something that is different is that we have something called the initial side and the terminal side. I call the initial side the starting side, the side that we're going to start when we try to measure the angle, and the terminal side's where we finish. So for measuring an angle, we always start with the initial and go to the terminal. Start with initial, into the terminal, and that's where we kind of call the angle, whatever we're going to call it in degrees or radians. Any questions on this here so far? And this here is just a picture of an angle. Now, we have these three definitions here. We have a positive angle, a negative angle, and the coterminal angles. Now, we consider an angle to be positive if it's going clockwise on the axis here. If we're going in the clockwise directions on this axis, it's considered to be positive. Negative is going to be counterclockwise. So on the XY axis, we'll have positive and negative angles. Now, given a basic axis, the initial side will always be the positive x-axis. We will always consider this here to be the initial side, not terminal. The initial side, I don't know why I'm wanting to say terminal. But the initial side will always be the positive x-axis. And we'll go in one of two directions from here. We're either going to go clockwise, which is our positive direction, or, counterclockwise for positive. I got them flipped. Sorry. This must be our Monday. Yes. Positive is our counterclockwise. And negative is clockwise. If you need an eraser, I have one. It seems a very opposite way to go because positive doesn't seem like we would go counterclockwise, we would go clockwise because that's the way we're used to going. But the best that I can reason out is this is really a lot of what we use trigonometry and geometry is with angles and navigation. And if we think of it as looking out, especially with astronomy, we can consider the kind of line of sight, if we're looking dead ahead, as the positive x-axis. And if we're talking about triangles and stars, looking up would be kind of their positive angle, which is our counterclockwise direction. So that's the best I can reason it out. But if we're talking about a positive angle, we're going counterclockwise. If we're talking about a negative angle, we're going clockwise. These are our two directions. Questions on any of this here? Now, coterminal angles is not something that we've covered too much about. And what this is coterminal angles are two angles that will get us to the same point, or same angle. Now for this here, we could say that this is 120 degrees. We're going 120 degrees counterclockwise. Well, what's an entire circle? An entire circle is 360 degrees, yes? Well, we could also talk about this angle in a negative direction, going the other way. And this here we can say is negative 240 degrees. They get us to the same spot. And these here would be coterminal angles. So coterminal angles are two angles that get us to the same location. Questions on this here? And again, all we need to do to find it, so if we're given the positive direction, we can subtract 360 from it. So if I subtracted 360 from 120, so we'd actually be saying 120 minus 360 will give us negative 360 would give us negative 240. And we get to this here. Now these two aren't the only two coterminal angles, because we could keep going. I could keep subtracting 360 from it. Because if we go another 360, it'd be taking it and going around again. 0. So it would also be the same as negative 600. And I could do it again and again and again, and we would continue to get other coterminal angles. Well, we don't just have to subtract. We could add 360, which would give us 480, because this time we're going the other direction, because we can add to those angles. We can go in any direction. Questions on this here? Now, radian measure is something y'all have heard about but not dealt with too much. Radian measures is really talking about along the circle. You determine the measure of an angle by the amount of rotation from the initial side to the terminal side. One way to measure an angle is in radians. This type is especially useful in calculus, and we can determine it here, because our angle is equal to, here, angle is equal to the side over r. So this over r. And S is equal to 2 pi r. Well, how's it going? No, you're good. And with radians and degrees, they're going to be about the same, because 2 pi r, we know that's the circumference of a circle, yes? 2 pi r. And really, pi is a better approximation for a circle going all the way around. 360 is not. But we still use 360 because, well, 360 is a nice number. It works out well. And a lot of mathematicians are kind of like, when they looked into this and talked about it, or kind of figured out why they chose 360. And it's mainly because, or what we've come to believe, is that they found it to be a perfect, or a nice number, a perfect number. Most of y'all, if you go to college, you'll end up having to take probably a psychology or study a lot of the Greeks, Pythagoras, Plato, Aristotle, Socrates, like all of these guys. And one of the biggest things that they were all searching for was perfection, this perfect ideal world, perfect. They were really obsessed with this perfect deal, and what they believed to be the perfect shape was a circle. They believed circles were the perfect shape. They believed the universe was kind of all founded around circles, that planets revolved in circles, and everything was this circle. And spheres were kind of the next level up. They were a circle of a circle. And they said, well, for this perfect shape, we need this perfect number, and they believed 360 was a perfect number, and it's a really nice number. Especially when we start talking about angles and measures with sine, cosine, tangent, we start using it. 360 is very nice. Because as we know with pi, is a non-repeating, non-terminating decimal. So when they actually started getting more into it and later on, they realized the circle is not as nice as what they thought, especially with measurements. So our two measures are degrees and radians. So a full circle is 360 degrees. A full circle in radians is 2 pi r. Now, one way that we can distinguish between the measures, radians will sometimes give us the measure in RAD or pi. Pi should be a giveaway if it is in radians, or it has RAD afterwards. One giveaway for degrees is our little circle here. It's telling us that it's in a degree. Questions on any of this here so far? Now, half a revolution, so half of 2 pi is going to be pi. 1/4 of a revolution, so half of a revolution is this one here. A fourth, so 2 pi over 4 is pi over 2. Or we can do any of these here, comparing it to a circle and how they relate to each other. And 2 pi is going all the way around. Questions on this here? And we can say the same thing in degrees. Now we know that the quadrants are numbered 1, 2, 3, 4, yes? Has it ever been kind of, for any of y'all that have thought about it, found it kind of odd that we go 1, 2, 3, 4 in this counterclockwise rotation? Because, I mean, it's never been stated in Algebra 1, 2, geometry. We never stated why this is, but we've always kind of accepted 1, 2, 3, 4. Yes? But which direction do we have positive angles? They go counterclockwise, yes? Well, the way we're numbering it is 1, 2, 3, 4. We're going counterclockwise. That's kind of probably what they were doing also, is that counterclockwise rotation, that positive rotation going around. Now, here is a good way we can kind of look at the angle. So at 0 radians, we're right here on the x-axis. Between 0 and pi over 2, we're in the first. Between pi over 2 and pi, we're in the second. Between pi over 2 and 3 pi over 2, we're in the third. And between 3 pi over 2 and 2 pi, we're back at the x, or in the fourth quadrant. Yes? Questions on this here? Well, could we keep going? Well, yeah, because we could keep going around the circle. So I could add pi over 2 to 2 pi, which I believe is 5 pi over 2. Here we would have 3 pi. And we could keep going round and round and round, because again, all of these would just be coterminal angles. So if we wanted to figure out which quadrant an angle lies, I would get it back between 0 and 2 pi, or 0 and 360 if we're talking about degrees. And we can figure out which quadrant it is. If we're talking about degrees, well, that one's going to be still 0 degrees. Straight up is going to be 90. Our negative x-axis is negative 180. And straight down is negative, or it's just 270. And then we come back to 360. So even if we're given an angle of anything, and we pull it back to this here, we can figure out which quadrant it's in. Questions on this here? Now, the first thing we want to do here, and kind of working with some of the problems, is finding coterminal angles. Now, the best way we can find coterminal angles is either adding, for radians, adding 2 pi or subtracting 2 pi. Now, the homework will probably ask for specific, say, 2 positive and 1 negative, or 2 negative and a positive. So if I wanted to say find the negative coterminal angle of 13 pi over 6, well, we can subtract 2 pi from it. Now, with the graphing calculator, it's not going to like pi. It's going to really, it may try to convert it to a decimal. So we can try this here. So we can look at the first one, 13 pi over 6. So in the graphing calculator, we can go alpha y equals enter 13, and pi is right here over 6. And if I want the negative angle, we can subtract alpha y equals enter. Oh, sorry, 13 pi over 6. Now we're just subtracting from it 2 pi. I don't know why I wanted to try to do a fraction. All we need to do is subtract 2 pi from it. Now, if we were doing this by hand, which is probably why I was doing the fraction, we would have to write it as a similar fraction. We would need the denominators to be the same. But the calculator doesn't care. Now we get this here. Well, we can go math, enter, enter, and okay, so it's not wanting to recreate it. Because again, it's approximating pi. It's trying to get as close to the real answer as it can. Well, what do we know for sure is going to be in our answer? Well, we're going to have pi, yes? So another way we can get at it with this calculator is say 13 over 6 minus 2, 1/6. Now we can multiply this by pi, and I'm only multiplying it by pi to show us that these are the same answers, yes? So our coterminal angle for this would be pi over 6. Because we'd put the pi, multiply it back on top, so we get pi over 6. Do we have a negative angle? So we found pi over 6, yes? Is that a negative coterminal angle? Well, no, there's not a negative in front of it, right? So what did we find? We found one positive coterminal angle. So what can we do to find the negative? Almost. What did we do? Because we subtracted 2, yes? We can do it again, yes? So we could say 1 alpha y equals enter 6 minus 2. So the next coterminal angle is what? Negative 11 pi over 6. Questions on this here? If we wanted to find another negative, all I had to do is subtract 2 pi again, or subtract 2 again. It would give us another negative. If we wanted to find a positive angle, well, I wouldn't start at pi over 6. I'd start back at negative 13 pi over 6 and add 2 pi, or add 2 to it. Because really, to find coterminal angles, we're either subtracting 2 pi or adding 2 pi, if we're talking about in radians. Questions on this here? Now, we will eventually get to the point where we talk about a radius, a length, and degree measure, or angle measure. And there's different ways we can talk about those, but we'll delve more into that later on. Questions on any of this here? So for negative 2 pi over 3, well, we have one negative angle, yes? If I want to find its counterpart, its positive counterpart, what can we do to it? We can add 2 pi. Now, as we already saw, really? So negative 2, alpha y equals enter. Because we're negative 2 pi over 3. And this time we're going to add 2 pi. Now again, we left the pi out for these here, the graphing calculator, because it's going to want to try to approximate it. But if we add these two together, we get 4/3, which would be 4 pi over 3. Any questions on any of this here? Questions on any of this so far? Which quadrant would these angles here lie? Now this might be hard to see with 13 pi over 6 and 11 pi over 6. But if we look at pi over 6, it might be a little bit easier to see because we're talking about 1/6. And on the xy coordinate plane, we have 0 right here, yes? Going straight up is pi over 2. Here is 1. Here is 3 pi over 4, yes? Now, pi over 6 does have the pi, yes? So really, if we look at all these, since it has pi, the rest have pi. We don't have to focus too much on the pi. But here, up top is what? 1/2, yes? Is 1/6 greater than or less than 1/2? Less than 1/2, yes? So that angle should be over here in the first quadrant. Because if we look back at the x-axis, because we had it on the page probably right above what we're looking at, that first quadrant's between what? 0 and pi over 2. Now, pi divided by 2 is this here. Pi divided by 6 is 0.52. It is less than it, so we're going to end up in the first quadrant. Does that make sense? And I mean, we could approximate the decimal and see if where it lands, but that would be the first quadrant. Now we can look at B, 4 pi over 3. So the main fraction is 4/3, yes? Is that greater than 1? Well, yes, it's greater than 1. Well, when it's 1, it's at pi, yes? So that means it's not in the first or second. So we're looking at the third or fourth quadrant. Fourth quadrant. Just that third or third. Now, is 4/3 greater than... Well, but there should be 4/3. So it's actually right there on the line. It's between the second and third. Or third and fourth, sorry. Quadrants. It's actually not neither one. It's right on the line. Questions on this here? Coterminal angles with degrees. This one here you'll find a little bit easier because this time we're not adding or subtracting 2 pi. We're adding or subtracting what? 360. So with 135, if I wanted to, I could add 360 to it. 5, 9, 4. So there'd be a coterminal angle. The other way we can do this is take 135 and subtract 360 from it. No, not 2. Nope. I don't know where I got that other 5 from. Because we'd have 5, or the one, 4, 2. That makes more sense. Negative 225. But again, you can plug that in a calculator and get the answer. And these here are just 2 of the coterminal angles. All we'd have to do is keep adding or subtracting 360 from those to get more. Questions on any of this here? Now 540 is a little bit different because this time, well, is 540 bigger than 360? Yes. And what's interesting about this is if I subtract 360 from it, 0, 2, because this would be 4, not 2, there's 6, 8, I don't know why I'm 8, 1, so 180. Just trying to do that backwards for a second there. So 540 minus 360 would give us 180. So this time when we subtracted 360, we didn't get a negative, we got a positive, yes? Well, now we can just subtract it from 180 and get negative 180. So if it's a bigger number, a bigger positive number that's greater than the 360, we can just subtract it from that number. Does that make sense? And the same thing is true if instead of 540, if we had negative 540, we would start adding to get the positive. Because the first time we add it, we would get another negative, but we'd have to add it again before we get a positive. Any other questions on this here? Any questions on anything we've done so far? Complementary and supplementary angles is next. What does it mean if two angles are complementary? They add up to be, I know it's been a while, 90. Complementary is 90, supplementary is 180. Complementary means they add up to be 90 or pi over 2. Because pi over 2 is going to be 90 degrees. Supplementary is 180 degrees or pi. So if two angles add up to be 180, they are supplementary. Or if they add up to pi, they're supplementary. And if they're complementary, they add up to pi over 2 or 90. So if we want to find the complementary and supplementary angles for 2 pi over 5, well, the first thing we can do is subtract 2 pi over 5 from pi over 2, or 1/2. So for this here, if we want to find the complement, we can say 1/2 minus, and our other angle is 2 pi over 5, or 2/5. So we can say alpha y equals enter 2 over 5. Questions on how we did that there? So we get 1 over 10, or for this here, it would be pi over 10 would be the complement. And the supplement is we're not going to subtract it from 1/2, we would subtract it from what? 1, just pi. So we can say 1 minus alpha y equals enter 2 over 5. And we get 3/5, so 3 pi over 5. Questions on this here? And I mean, realistically, mathematically, if we're looking at this here, we were saying that 2 pi over 5 plus x is equal to pi over 2. And the same thing with pi. Then we would subtract to solve. We would subtract the 2 pi over 5 from both sides, just telling us x is equal to pi over 2 minus 2 pi over 5, which gives us our pi over 10. The same thing, we would do the exact same thing to find the supplement, except instead of having it as pi over 2, we would have it as pi. Questions on this here? We ready for the next one to do 4 pi over 5? Well, we're doing the exact same thing. As we can just pull up the calculator and say 1/2 minus 4 over 5. And we get negative 3/10, yes? So this one here actually doesn't have a complement because 4 pi over 5 is actually bigger than pi over 2. We don't have two positive angles because when we look at complement and supplement, we're really looking at the positive angles. So it doesn't have a complement. but that doesn't mean it doesn't have a supplement. Because we can say 1 minus alpha y equals enter 4 over 5. And see, okay, it does have a supplement. Its supplement is pi over 5. No complement, but its supplement is pi over 5. Questions on any of this here? Because the pi, dealing with radians, is a little bit different. You haven't worked with that before. Now, that's why I put 2 of those there. Now, the degrees, y'all have worked with before. Because if I want to find its complement, we would do 90 minus 65, which would tell us that it is 25 degrees. If we want to find its supplement, we would take 180 minus 65, which would be 115 degrees. And y'all have done that before. It's a little bit nicer than dealing with radians. Are there any questions on any one of these, either one of these? Do you feel kind of comfortable with complement, supplement? Okay. This here is the last thing we're going to talk about today. We'll finish these up tomorrow. Radians to degrees or degrees to radians. 180 is equal to pi. 180 and pi are the same. 2 pi and 360 are the same. So if we want to revert from degrees to radians or radians to degrees, we're going to use this here. Now if we're going to radians, radians is equal to the degree measure times pi over 180. If we're wanting to go to degrees, it's equal to radian times 180 over pi. So if we're going from radians to degrees, we're going to multiply the radian amount by 180 over pi. If we're going from degrees to radians, we multiply it by pi over 180. And doing these here, it's going to be a lot easier to do them on the 30XS, the yellow calculators, not the graphing, because the yellow calculators will actually work with these, especially the degree measures, in terms of pi. It will not simplify to a decimal. It'll keep it in those terms. So for this first one here, since we're talking about degrees, means we're going to radians. So we would take 135 and multiply by pi over 180. We know we'll leave our answer in terms of pi. Because unless we absolutely have to simplify it to a decimal, I leave it in terms of pi. So we have 135. And we're going to multiply it by alpha y equals enter 1 over 180. Because the 1 in place of 1 would normally be pi, but as we've seen already, this calculator converts it to a decimal. So we can hit enter, which reverts to 3/4. Or it's going to be 3 pi over 4. So the radian measure for 135 degrees is 3 pi over 4. Questions on this here? Let's do a radian to degree. So here we're told that we have negative pi over 2, yes? So negative pi over 2, we're going to multiply this by 180 over pi, yes? What do we know about the 2 pi for this here? What's going to happen? They're going to cancel out because I would end up with pi over pi. So these would cancel. And we know our final answer is going to be negative, yes? What would be in the numerator? That's the only thing left on top. 180, yes? What's the only thing left on bottom? So we would have what? 180 over, what's 180 divided by 2? And that's it. Now we could have written that out. I could have written as negative 180 over 2 and then simplified, but I felt like y'all had a good enough grasp on this to say, okay, 180 divided by 2 is 90. Or in either calculator for this one, we could have typed that straight in and it would have given us the answer. Because pi and pi cancel, it's not going to give us an ugly decimal, and it'll give us the answer. Questions on this here? Let's look at these last two here. So to turn 540 degrees into radians, we've got to multiply by what? Pi over 180, yes? And what do we know will be in the answer? Pi, yes? So really, what are we doing? We're taking 540 and dividing it by 180, yes? So we could come over here and say 540 times 1 over 180, and we get 3. Or I could say 540 over 180, because that's really what we end up doing. We're dividing 540 by 180. If we get a decimal, so yeah, we could have just said 540 divided by 180. I could have just said division. If we got a decimal, we can convert it back to a fraction and go from there. But it's just telling us that it's 3 pi. Now, actually, we'll finish up with this one. Because normally I already wrote a fraction. Probably some of y'all did too. You could erase it, or you can turn it as part of as you're circling the answer. All right, guys, we'll finish this up to tomorrow.